This one is 2.13. Here we have to look at example 2.3 here, and in here we have to show that for general values of spring constant, the deflection at point A when load is applied at x equals to delta A is same as deflection at x equals to delta A when the load is at point A. So basically in first case we are applying load here and checking for delta here, and in the second problem we are switching the role of these two. So if I redraw this configuration one more time, so in the second problem now our force P is right here and we are interested in delta at this point where this distance right here is lambda A. Spring constants are same, so Ka, Kb and Kc. Now how do we solve for this delta? We can start this problem from the scratch and solve for the forces and then apply the geometrical compatibility, moment balance, and we can get the value of delta. But since we already know the solution to the first problem here, we will use the lambda parameter to our advantage and we will try to modify the first problem by adjusting the value of lambda so that this problem can be solved. So what is lambda deciding here? Lambda is deciding the location of force P. So if I increase the value of lambda on the positive side, at lambda 0 force is going to be applied here, and at lambda equals to 1 it ends at this point. Similarly on the negative side, when you are moving this way, at lambda 0 your force is at B, and when lambda becomes -1 your force is going to be acting at point A there. So in these solutions, if I substitute lambda value equals to -1 here, I will be able to get the value of displacements delta A, delta B and delta C for the second problem. So if I substitute these value lambda -1, I'll just say that this force P and this denominator D, I'll just keep this as common. So P over D is common because it's same in all the terms. On the top here we are going to get 2 times Kc and lambda -1, so minus Kb minus 2 Kc. Similarly your delta B is P over D Ka plus Kc minus Ka plus Kc, and the last one P over D 2 times Ka minus Kb minus 2 Ka. So you can see that this cancels out with this one right here and this one right here. So all of these terms here P over D is common, and in this one we have only minus Kb, here we have 2 Kc, and here again we have minus Kb. Now this delta value is the value of displacement at a distance of lambda A from point B, right? So since we already know the value of delta B and delta C, we can interpolate between these 2 points and we can find the value of delta. So now if I separately draw this delta B and delta C here, now this side is your delta B and this side is your delta C, and we are interested in delta right here, which is sitting at a distance of lambda A from point B. So this delta can be divided into 2 parts. One is this part right here and this one, which is a separate small distance. Now I can extend this line so that I can get 2 triangles. So this part right here is equals to delta B because these two are exactly same. So delta will have one part coming from delta B, and for the second part let me call this delta dash. Okay, now delta dash divided by lambda A from this triangle need to be equal to this height right here, which is nothing but delta C minus B divided by this width here, which is the gap between B and C, which is equals to A. So this A and A cancels out, so your delta dash is going to be delta C minus delta B times lambda. So I can add this part here, so this is delta C minus delta B times lambda. Now I can substitute these values that I have solved earlier, so now a delta becomes P over D, which is common. Now delta B value is 2 times Kc plus lambda. Your delta C value is minus Kb and minus delta B again minus 2 Kc. So now if you compare this, P over D brackets 2 Kc minus lambda kb plus 2 kc. So now you can check that this matches perfectly with this value of delta A. First term is 2 kc here, 2 kc there. Second term kb plus 2 kc with minus lambda, which is matching exactly there. So you can see that when we have a deformation problem, and if we mutually switch the location of force and displacement, the answers are going to be exactly same here.